Section 5.3 Double angle formulas. This section we are going to use double angle formulas to find exact values of trigonometric function and also use to prove trigonometric identities. Let's get started with what we did in the last section is about the sum formula of the psi. From the formula psi of a plus b equals psi a times cosine b plus cosine A times sine B. In this case, if A equals B, or sine of A plus A, which is the same as sine of 2A or sine of double angle A, is going to be sine A times cosine A plus cosine A times sine A. The other way we say we replace B with the A. And after we replace in the formula of the sum formula of the sine function, we have sine times cosine added by another sine times cosine of an angle A. Therefore, the sine of double angle or the sine of 2A is twice of the product of sine A and cosine A. Similarly, when we look at the sum of the cosine the sum of the angle of the cosine function or sine of a plus b, which is cosine a cosine b minus sine a sine b. For the case that a equals b, we look at cosine of a plus a or cosine of 2a. Replace b with the value with the angle a from the sum formula of the cosine function, we will get cosine A times cosine A minus sine A times sine A. That gives us cosine square of an angle A minus sine square of an angle A as the formula for the cosine of the double angle. That gives us another formula, which formula for the double angle of the cosine function. And recall for the trig identity that cosine square A plus sine square A equals 1. If we replace sine square A with 1 minus cosine square A, this formula becomes cosine square A minus the quantity 1 minus cosine square A. Distribute the negative sign into the parentheses. So we have negative 1 plus cosine square A, and that will give us two terms of the cosine square of the A, or 2 times cosine square A minus 1. And this is another form of the cosine double angle of A. Another way, if we are going to solve for cosine from the Pythagorean identity, cosine square A is 1 minus sine square A. This time we're going to replace the cosine square A with 1 minus sine square A. Therefore, we have 1 minus sine square A minus sine square A. As you see, we have two terms of negative sine square A, then simplify to be 1 minus 2 times sine square A as another form of cosine double angle A. That means cosine double angle has three different forms. As summary, double angle formula for the sine function is sine of the 2a equals twice of the product of the sine A and cosine A. For the double angle formulas for the cosine function, there are three different forms. The first one is cosine square A minus sine square A. The second form is twice of cosine square A minus 1. The last form is 1 minus 2 times sine squared of the A. Which form we're going to use, it depends on the problem that we are working on. If we are solving the trig equation, if the term has other, if the equation has more terms involving cosine, we're going to use the cosine version. If in the equation involving more terms inside, we're gonna use the sine version. So it depends on situation or the problems that we are working on. For the double angle formulas for the tangent of the a of the function or the tangent of the 2a is 2 times the function tangent a divided by 1 minus tangent squared a. The way to prove is similar to the one that I showed before. The tangent of the 2a is from the tangent of the a plus a, and we use the sum formula for the tangent as the tangent a plus tangent b all divided by 1 minus the product of tangent a and tangent b. Once we replace b with an angle a, we derive the formula in the box as tangent of the 2a equals 2 times tangent a divided by the quantity 1 minus tangent square a. Let's look at the example. The first example, let's sine a be negative 4 over 5 with a in the fourth quadrant. And we are going to find sine of double angle, cosine double angle, and the tangent of double angle. Since a is in the fourth quadrant, so let's draw the xy plane. For the fourth quadrant, sine is from y divided by r. Therefore, the y is negative 4 and the r equals 5. We can find the x by using the Pythagorean theorem or r squared minus y squared to obtain the square root of 5 squared minus the quantity negative 4 squared simplified to be square root 9 or 3. Now we get the value as, let's summarize it over here. So x equals 3, y equals negative 4, and r is 5. And draw the diagram in the fourth quadrant as x positive, y negative. We have the right triangle or the angle A located in the fourth quadrant. 3 here, negative 4 here, and r is 5. We're going to use this triangle or the numbers for the x, y, and r to find the sine of double angle, cosine double angle, and tangent double angle. From the formula, sine of 2a, a sine double angle, is 2 times cosine a times sine a. And the cosine of double angle, there are 3 different forms. We just pick one of them. I'm going to use cosine square a minus sine square a. And the double angle formula for the tangent is twice of the tangent a divided by 1 minus tangent square a. Or we can use the numbers that we would derive from part A and part B as sine of double angle 2a divided by cosine of the double angle or the cosine of 2a. So either one. Now, from what we have, since the sine A is negative 4 over 5, what we're going to use in the formula would be the term cosine A and sine A. Right. And we know the x value. Therefore, by definition of the cosine A, which is x over r, then the cosine is going to be 3 over 5. Now we use the numbers for the sine and cosine replaced in the formula for the double angle of the trig functions. For the sine double angle, we have 2 multiplied by the cosine A is 3 over 5. The sine of the A is negative 4 over 5. Simplify the number as 2 multiplied by 3 multiplied by negative 4 divided by 5 times 5. And turns out to be negative 24 divided by 25 for the value of the sine of double angle A. For cosine of 2A, replace the cosine A with the 3 over 5 and square it. subtracted by the value of the side, which is negative 4 over 5, square it. The square of 3 over 5 is 9 over 25. Negative 4 over 5 squared is 16 over 25. Subtract these two fractions. So then we will get the value negative 7 over 25 as the value of the cosine double angle A. Now we're going to use these two numbers to find the tangent of double angle A. The sine value is negative 24 over 25 divided by cosine of double angle, which is negative 7 over 25. As a complex fraction, we rewrite it as negative 24 over 25 multiplied by the reciprocal of the denominator, or multiplied by 25 over negative 7. We can reduce 25. So we get the tangent of double angle equals negative 24 over negative 7, or just positive 24 over 7.